We're going to continue on with our example with these law school candidate prep times versus their test scores. And if you recall, we got the data here, and we found the least squares regression line, which is right here. That's our prediction line, where we would plug in the number of days they studied, plug it in, work it out, and we'll get our predicted score for their law school candidate test. So this video is going to talk about the residuals. What is a residual? What does it mean? And all the things you need to know about residuals. So if you recall from the last video, I was able to graph this using some software. And the line of best fit, if I draw it in, will probably be something like this. Going through these points, some above, some below. Actually, that's not that great. Let's see if I can try that again. I'll erase that. Okay, let's try that again. That's a little bit better. Sorry, it's not that straight, but you get the idea. So the line's kind of going through there. We're going to use that to make predictions. But what I want to focus on is something called a residual. As you can see, some of these points are close. Most of these points are really close to that line. But you might have some times where points are a little bit further away if the correlation is not so strong. Now, the residual is the distance from the actual dot to the line, and it's you got to go straight vertical. So, for instance, if I'm looking at this point here, if I draw straight down to the line, and they're all very small residuals because this is a strong correlation, but that little distance right there is a residual. So every dot on this graph has a residual. If the dot was right on the line, the residual would be 0. If the dot's under the line, then you have a negative residual. And if the dot's above the line, you have a positive residual. And the formula is very, very easy. It's y minus y hat. Or in other words, the actual y value of the dot minus the predicted value of the dot. Right? This is the dot. This is the line. So very easy formula. So make sure you do the dot minus the line, and then you'll have it correct. And always look at your graph to make sure, if the dot's above the line, you're going to have a positive. If it's below, you're going to have a negative. So if it doesn't match, that means you probably switch these, which is very common. So as long as you check with the graph to make sure it makes sense, you're going to be fine. So let's see this in an example. Sherry studied 3 days, and she got a 12 on this test. We're going to find and interpret her residual. So the first thing you need to do, if you remember the formula what I just wrote, is y minus y hat. So we already know one of these things. We already know what she actually got. She studied 3 days, and she actually got on her test a 12, right? That's the y value. That's her test score that she actually got. So that's going to go right here where the y is. The problem is we don't know what her prediction is right now. So in order to get that, we need the least squares regression line. And if you recall, the least squares regression line was y hat equals, our predicted test score is 2.456 times the number of days studied, and we add on 3.298. So to get her predicted score, what we would predict her score to be, it's based off of the 3 days that she studied. That's the x value. So we'd plug that in. Work it out. You can use a calculator. And I get that we would predict her score to be a 10.666. So that's what we would predict based on her 3 days, but she actually got a 12. So 12 minus 10.666 is 1.334. There's her residual. Now the interpretation part. What does that mean? Well, we would expect her to get 10.666, but she got a 12, so she actually did better than what we thought, and that's why this is positive, because she did better. She was higher than where we thought she would be, based on everybody else's scores. So we would write something like this: Sherry scored 1.334 higher on her test than we would predict. So that's a residual. That's how you find them. And it's basically a measure of how far off was your prediction from the actual value. Let's do one more example. So Frank studied for this test 6 days, and he got a 14 on his score. Find and interpret his residual. So we're finding residual. The formula again is actual minus predicted. And from reading this, we have the actual score, which is 14. We need to get the predicted score. The predicted score is not 6. That's because that's not a score. That's a number of days. That's an x value. So we need to go back to our least squares regression line and plug that in. So I'm going to plug in 6. You can use a calculator, and we would predict a score to be 18.034. So that's going to go here. And notice the 18 is higher. We would expect him to get higher, but he actually got lower. So in this case, when we plug this in the calculator, we get negative 4.034, I believe it is. So his residual, he actually scored 4.034 lower than what we expect. So that's what we would put in our interpretation. So Frank scored 4.034 less than expected on this test. So now that you know about residuals, the last thing you need to know is, and you're going to see this in printouts, you'll never have to find this, although I think Mr. N's kind of showed you, but on the AP exam you'll never have to find this. But it's a value called S, and that is the standard deviation of the residuals. Now, for the AP exam and for your test, what you're really going to need to know is how to interpret that value. And to interpret that value, you need it. All you really need to say is it's how, on average, how far off our prediction is from the actual values on average. So it's a measure of how far off, on average, our prediction is from the actual values. And you would add context, of course. So you would say how far off, on average, our prediction for test scores are from the actual test scores. Okay, so that's pretty easy, and I'm sure you'll do more examples in class.